I will introduce some of the really cool initiatives underway to make geospatial data more accessible. For those of you who are not familiar with AidData, we are a research lab within the College of William & Mary down in Williamsburg, Virginia. Our work tends to focus on using data and innovative methods to help international development organizations improve how aid is targeted, monitored, and evaluated. We work with partners from around the world to collect new data, conduct surveys, explore new applications of machine learning, employ rigorous research methods, all to address real-world development problems. What we're going to be talking about today, and a major component of the work we do at AidData, is geospatial data. Geospatial data is growing in terms of the quantity, quality of information collected from a whole range of different satellites, phones, smart devices, and other sources. And it's just overall seeing a growth of use in new applications across fields that are themselves new to using geospatial data. To that end, our first talk today will introduce AidData's GeoQuery platform, which looks to make geospatial data more accessible to a wide range of users. Then we're going to dive into how AidData produces one of the data sets offered through GeoQuery on the location of Chinese development activities around the world. And then finally, we're going to take a look at how William & Mary's GeoLab collects the boundary data for every country in the world, which is used in GeoQuery among a whole bunch of other applications. All of these tools and data are 100% free and open source. We're not selling you anything. And whether it's the first you're hearing about geospatial data and just want to learn more, or if you're familiar with geospatial data, interested in learning about new data source and activities, I think today's talk will have something for everyone. Each of the talks will be about 10 to 15 minutes with 5 or so minutes for Q&A after. At the end of all the talks, we can use any time remaining for additional questions and discussion. So for now, I'll turn things over to Soren for our first talk about GeoQuery, AidData's free tool that provides open source geospatial data in a simple and easy use format. Soren?
Thanks so much for the introduction, Seth. And thank you all so much for coming to our event today. We're really happy to be here with you. I'm Soren, a communications associate here at AidData. Before I begin, I want to let you all know that these slides will be made available to attendees after the event, and they contain links to more information. So if you have any questions as you go along, please put them in the chat and we'll address them during the Q&A period. And we're also happy to stick around to chat afterwards, like Seth said. So I'm excited to speak to you today about GeoQuery, which is an initiative of AidData to make geospatial data more accessible and useful for those who may have no experience with it. GeoQuery.org is a completely free online platform that anyone can use to create customized data sets for the geographic areas of the world and the topics in which they're interested. So I'll get to more about how GeoQuery works and why we developed it in a moment. But first, why does geospatial data matter and what is it? Well, briefly, geospatial data is just data that has location information attached. There are many different types and file formats of geospatial data, but I won't get into those here because the crucial thing is you don't actually need to know how to use any of those to be able to use GeoQuery. As for why geospatial data matters, so 3 years ago, this article ran in Forbes with a pretty eye-catching headline: "Geospatial analytics will eat the world and you won't even know it." I think that this title was not hyperbole. Today, there are terabytes upon terabytes of data that's rich with location information that is being unlocked from a truly dizzying array of sources, from satellites to ground-based surveys and much more. And the value that that data holds and the promises of the challenges that it could help solve is only growing. For example, in 2012, geospatial applications for agriculture and construction in the US alone exceeded revenues of 1.4 trillion and cost savings of 1.6 trillion. So that was just 2 sectors in one country. And since then, those specific figures have only doubled. So why do we need geospatial data? We need geospatial data, especially subnational data, to move beyond what's been called the tyranny of averages, where looking at only national level data hides patterns and hotspots of inequality. So in this example map that I made of 2 countries in West Africa, average child mortality at the country level is pretty similar between Nigeria and Cameroon. 34.1 for Nigeria, 28.5 for Cameroon. But looking at the subnational data reveals that there's actually wider variation within the 2 countries than there is between them. So there's a clear spatial pattern where northern areas of both countries have much higher rates of child mortality. A similar example from AidData's research is that we and others have found that more aid does tend to go to poorer countries, but not to poor regions within those countries. So one of our research questions at AidData is, can we develop methods using subnational geospatial data to help allocate aid more efficiently? This means identifying places that are overlooked and in need of aid, determining the conditions under which projects have larger impacts, and then getting this information to the right people to drive policy and decision-making. So it's clear then that knowing what is happening, where and when is powerful, which is why an increasingly diverse range of organizations, including nonprofits and grassroots groups in the Global South, are looking to use geospatial data to produce meaningful insights that may end up helping solve some of the world's toughest development challenges. But for organizations without significant computing power or data science expertise, there are barriers to overcome. For example, there are countless data sources with different formats and quality. You often need specialized technical knowledge to understand the raw source data. What are the limitations? What processing has already been done to it, et cetera. In addition to knowing where to look for data, you need the ability to download, clean, and prepare the data into a usable format. Finally, there's the problem of aggregation. Spatial data often needs to be summed up or aggregated to meaningful units of analysis, things like countries, regions, cities. For example, you could have data on temperature that's in a grid format covering like the entire United States. So you could have a temperature value for every single 30 by 30 meter square of land in the US. But if you then wanted to know average temperatures for counties, you'd have to aggregate that data according to county boundaries. Normally to do this, you would need either to know specialized GIS software or know how to write your own code to do this aggregation. Finally, to use truly large amounts of geospatial data, terabyte amounts, you would need access to the computing power and the storage to actually process that data in a reasonable time frame. All of this makes it hard for decision makers and organizations to effectively find and use geospatial data. This is where a platform like GeoQuery comes in to help. GeoQuery is a free groundbreaking tool that provides access to open source, high quality geospatial data sets in a simple format. So behind the scenes, GeoQuery is using a high performance computing cluster, basically a supercomputer, to process terabytes of data, allowing anyone to find and aggregate dozens of data sets into a single spreadsheet, solving that aggregation problem I just mentioned. So basically in GeoQuery, you select a boundary you're interested in, say regions in Kenya. Then you select from a large list of available data sets the data you want. In this example, climate and population data. You enter your email and the result is that you get emailed a link to download a CSV where every row is a district in Kenya in this example, and every column will be a variable of interest, in this case, maybe yearly rainfall data and population. In fact, so AidData researchers, specifically Seth Goodman, who introduced this event, first created GeoQuery as an internal tool to help us, to help our researchers wrangle massive amounts of geospatial data that they needed for our impact evaluations of development programs. But we realized what a powerful public good it could be, and so we made GeoQuery free and open source in perpetuity. And this was thanks in part to generous funding from our partner, the Cloudera Foundation, and other foundational investments from William and USAID and the William and Flora Hewlett Foundation. So since we officially launched in 2018, GeoQuery has fulfilled more than 20,000 data requests from users at more than 1,000 organizations. And thanks to these funders and partners, we've been able to improve GeoQuery's infrastructure, enhance accessibility, and make just more data sets available. So briefly, GeoQuery has 5 key features that make it work. Expert curation is one. All of the data sets in GeoQuery have been hand selected by our experts. So going in, you already know that the data is high quality. It's clean, so the data you request gets exported to a simple CSV file. If you don't know what that is, that's just a comma separated values file that you can open in any spreadsheet program like Excel or Numbers or another program like R or Stata. User interface, the key feature of GeoQuery is that you can filter for and join all of these data sets together to the geographic boundaries you want without needing to use any code. Finally, GeoQuery is documented and replicable. You automatically get all the documentation you need, like sources and references, with your dataset download, and you also get a permanent link to your dataset request online, so you can always go back and download it again or share it with someone else. So I've talked a lot about datasets in GeoQuery. So which exactly data is available? GeoQuery has more than 65 satellite, economic, health and conflict, and other data sets that span decades and are available for pretty much every country and territory in the world. These are all open source data sets that our team has curated both from AidData's own data and data of external organizations. I'm going to click on the datasets link here, which will bring me to a webpage that covers the data sets and all of their sources. So if you want to know more about an individual data set, you can come to this page. So rather than going into detail on every single data set, I'll just highlight a couple of GeoQuery's most requested data sets. One is yearly data on nighttime lights from around the world. We have data from two sources, one that covers 2012 to 2018 and another that covers 1992 to 2013. Another popular data set is one that AidData created, capturing Chinese government finance development projects around the world. Our global Chinese official finance data set tracks nearly 3,500 individual projects, collectively worth almost $300 billion, that were implemented across more than 6,000 locations from 2000 to 2014. So this data set is available in GeoQuery and can be merged with all of these other data sets that you see above. And here's a sneak preview. In the talk following mine, Catherine Walsh, a program manager at AidData, is going to give an overview of the work that AidData researchers are currently doing to update and expand the scope of this massive data set. Oh. Sorry about that. It looks like we skipped a slide. There you go. So next, I'm going to show you hands-on how to make a data request in GeoQuery. So we have various levels of administrative boundaries available for countries and territories around the world. In this case, I'm going to use the US as an example. So I'm going to type United States and I'm going to select Geo Boundaries, the Geo Boundaries available. Geo Boundaries is the world's largest open source data set of geographic boundaries, and it's produced by the GeoLab, which is another research lab at William & Mary. And Sydney Ferrig, who manages the Geo Boundaries team, will present later on that project. So now I can see the different administrative levels available for the US. In this case, I could choose the highest level, which is states, or I could choose the second administrative level available, which is counties. So I'm going to do that. Click Search Datasets. And real quick, can you all still, Seth, can you still see my screen?
Yeah.
Great. So now I can select data sets. In this case, for example, I'm interested in which counties in the US have the worst CO2 levels and the highest solar potential, because maybe I want to know where to potentially site new solar projects. So now that I'm looking at the data sets, I can filter by category. So I'm going to click Environment. And there's a huge list of data sets available, but I'm interested in CO2 concentration. And once I've selected a data set, I can see all the customization options for an extraction. So in this case, I can select mean CO2 for 2018, and then simply hit the yellow button, add to my request. I can keep doing this for each different data set that I'm interested in until I've assembled all of them into one request. When I hit submit request, I'll be asked to give an email. And then once my data has been processed behind the scenes by GeoQuery supercomputer, I'll get a link to my dataset request once it's fulfilled and ready. I already did this before the presentation though, so I'm just going to go ahead and go to the results page. So once I click the link, and this is the link that would have been emailed to me by GeoQuery, I can see a download page where I can download a zip file that includes my CSV of my data, and also includes a PDF of the documentation, and also includes a boundaries file that I can then use in GIS software if I so desire. So now that I have my data, I can do a lot of different things with it. Like I said before, I could use this data in Excel, Stata, R, Python, etc. Or I could join it with the spatial boundary data that I downloaded as well from GeoQuery for more advanced analysis. So in this case, I brought the GeoJSON file of US counties that came with my data request into Data Wrapper, which is a great free online tool for making maps and charts. And as a side note, these maps actually link to dynamic versions in Data Wrapper, which you can then duplicate and edit yourself. And I've also included in this presentation a link to a tutorial we put together on making your own maps in Data Wrapper using data from GeoQuery. So creating a map like this and visualizing this data on it allows me to see trends in the data that might not otherwise be visible at a glance, right? Just looking at a spreadsheet. For example, flares from natural gas extraction in North Dakota is what's contributing to the dark areas here above. And then another example of an outlier, interestingly, is Pinal County, an outlier for the state of Arizona. Why does it have a much higher average CO2 than the surrounding area? I did some research online, wasn't able to find a conclusive answer, but Pinal County does house the second largest city in Arizona, and it is or was recently the second fastest growing county in all of the United States. So those could be some reasons. So if I'm considering where to site, say, solar power projects or carbon capture projects, maybe knowing which kind of counties in the US have some of the worst CO2 levels would be really useful. Here's another map that I made from the same data request, just illustrating a different variable. In this case, solar power potential. Solar power potential is just a constructed index from the Global Solar Atlas, so it takes into account many factors, but we can see a clear spatial trend playing out across the US, right? Sunny counties in the West have the highest solar potential, and some of the areas with the worst potential are in the upper Midwest and around Lake Michigan. But there are outliers, like there are some counties on the East Coast that have as much solar potential as those in the West. Finally, I want to emphasize that you don't need to be making maps to get valuable use out of GeoQuery, right? The data you get in a request from GeoQuery comes in that tabular data format that can easily be opened and analyzed in Excel or another program. So here I use the data I requested from GeoQuery to make a scatter plot in Data Wrapper of the US counties with the worst CO2 levels in 2018. So the horizontal axis is solar potential, the vertical axis is mean CO2, and the size of the bubbles is the population of the counties in question. And a dynamic version of this chart is also available too in Data Wrapper. So that's all I have for today, and thank you so much for your time. I hope that this has empowered you with more options for integrating open geospatial data into your work and that you'll be trying out GeoQuery. Our contact information is provided here, so please do reach out if you have questions or if you have suggestions as well of new open source data sets to add into GeoQuery. And we'll be sharing these slides in a recording with attendees after the event. And I'll be including a survey as well for those who might be interested in a follow-up webinar that goes a little bit more in depth into using geospatial data and GeoQuery. We'll now transition into a period for Q&A that Seth will moderate before the next presentation. So if you have a question, please do put it in the chat now. Thanks.
Thanks for that, Soren. Looks like we've got a couple of questions in the chat already. I think some of these were addressed, but is this data available for every country in the world in GeoQuery?
Yes, or nearly. It's available for 195 plus countries and territories, I believe.
What was that?
Sorry, I was just going to say additionally, and I think Seth, you could speak to more on this, but data is available for an increasing number of administrative levels as well for each country. So for example, for France, in GeoQuery, we have data not just available for the 13 regions in France, but also for the, I don't know how many, the arrondissements, which is the next level down, and then the 3,000 plus cantons, and going down all the way down to the commune level, where in France, you could get data for, at the commune level, 36,000 communes in France.
We'll hear a bit more about how those administrative levels work in the Geo Boundaries talk in a bit. Next question was about whether the most recent data sets are based from 2018 or even newer. We'll go ahead and answer that. I think most of our data sets, the time frame varies depending on what's publicly available. Some have more data than what we've included in GeoQuery just because we haven't gotten to updating them all. I think 2018 to 2019 is currently about the newest we have, but we're constantly going back and updating those when we can. The boundary data that you get with GeoQuery, is that compatible with programs like ArcMap and GeoDA?
Yes, so the boundary data that you get with GeoQuery comes with as a GeoJSON file, and Seth, are shapefiles also included?
Just GeoJSONs at the moment, but those will work in ArcMap or anything else as well.
Exactly, you can bring GeoJSONs into ArcMap, and you can also convert them easily into like a shapefile. So yes, it works in ArcMap or QGIS.
Looks like we have a question about, can people load their own data sets? I guess it says CSV was mentioned, but just in general, maybe you could talk about what happens if people have their own data sets they're interested in.
Yeah, so if people have custom geographic boundaries they're interested in, like they want to have the data that's already in GeoQuery aggregated to, like let's say they have boundaries for national parks across Africa. They could submit a customized request, and we have a page for that. If they have data sets as well that they want the data in GeoQuery merged with, I believe that they can also use that requests page to make a customized request.
Generally, if they have their own data sets to be aggregated, we will take suggestions about data we're going to add into GeoQuery. Usually that can be a bit difficult to do on a case-by-case basis, but we're always open to it. We usually want to work with users to make sure everyone gets the data they need. Next question was, does GeoQuery pull NGO data?
Sorry, was GeoQuery pull NGO data?
Yes, I guess data from other NGOs.
Yeah, so I guess off the top of my head, I don't know the provenance of all of the different data sets in GeoQuery. A lot of the data is from like global research data sets that often universities have put together. But I think that some data does come from groups that maybe could be considered NGOs, like the Global Solar Atlas. Not quite sure who exactly puts that together. Seth, do you want to comment on that?
Yeah, that sounds pretty good. I mean, generally, we look for high quality data sets regardless of the source. I think less of our data sets come directly from NGOs. It's not sort of the informal data that we're kind of going out and just collecting from anyone that has information. This tends to be the highest quality global data sets out there that are already sort of research standards. Next question was about updating the China foreign aid data set. We'll hold off on answering that one. The next talk will address that, I promise. The other question was about APIs for GeoQuery. Currently, we do not have a public API for that. It's something we've considered, but there hasn't been a ton of demand for it. It looks like that's the end of the questions for now. If anyone has any other questions, we're happy to come back and talk more about this at the end of the event tonight. So for our next talk, Catherine will be providing details on the methodology used to uncover and track non-traditional development financing by sources like the China data that Sora mentioned, as well as some of the innovative research and findings that have been produced using this data to date. Catherine?
Thank you for that introduction, Seth. Hi, good evening, everyone. I'm glad to see so many have been able to make it to this talk. I'm Catherine. I'm a program manager at AidData, and I contribute to our work on underreported financial flows, including tracking China's global official finance. During this presentation, I'll provide an overview of the data set that we've assembled on Chinese global official finance, some of the insights we gain about China's global development footprint through that data, and also the process we use to assemble that data set. And I'll also highlight some of the improvements we've implemented in our data collection process that you can look forward to seeing in our next launch of the data later this year. So as you may or may not know, China does not report their development assistance flows to the creditor reporting system of the OECD, or the Organization for Economic Cooperation and Development, like other traditional donor countries like the US, Japan, the UK would do. So China doesn't necessarily adhere to the same standards for what development assistance should look like as other traditional donor countries do. And China also doesn't publish project level or country by country breakdowns of their international finance activities. So what we do at AidData is we leverage the tracking underreported financial flows methodology to track project level aid flows from China. And this is an open source data collection methodology, meaning that we use openly available sources online to find this information. So you could also reference the same sources that we do to verify these projects that we report on. The data set that we have available on our website and also through GeoQuery is the 2000 to 2014 Chinese Global Official Financing Commitments, which totaled 350 billion USD. So China is a huge emerging donor, so we can answer a lot of important questions by having this data available. And you can find more about this at aiddata.org/China. So as I mentioned earlier, China does not report on their development assistance flows to the OECD, but one key important feature of our data is that we capture the same fields that the OECD does in the way that we track our flows, our Chinese official finance flows. So you could compare our China data and Chinese financing activities with flows that are reported from other donor countries to the OECD. And we also have expanded field coverage beyond what the OECD tracks so that we can have a more comprehensive understanding of these Chinese financing activities abroad. We also have our methodology is publicly available through our website. So it's open to scrutiny, and we're constantly looking to improve the process that we use to collect this data and also the fields that we capture in the most meaningful way. And what's exciting about the methodology to me is that it can be applied to all different sorts of questions. So you could use tracking underreported financial flows to approach not only the way that you collect data about Chinese financing, but you could also look at other non-transparent or non-traditional donor countries, as well as other different types of financial flows. You could adapt the methodology to answer those sorts of questions. So through our website, we also have available a geo-coded version of that 2000 to 2014 data set. And again, this is also available through GeoQuery. And what you can view here is a snapshot of what that looks like in our website. And these glow points here show the relative size of different Chinese financing commitments at subnational locations throughout the world. So taking a little zoom in to these financing commitments, it's not just saying it's Chinese official finance and it just meets one criteria. There's two different types of flows that we're looking at when we talk about Chinese official finance. So for Chinese official finance, it needs to be from a government agency or some sort of state-owned bank, like a state-owned policy bank or a commercial bank. And also in our updated data set, we'll be including state-owned enterprises as one source of Chinese official finance, although in the 2000 to 2014 data set, we don't track financing from state-owned enterprises. So the two different types of flows you would expect to see in Chinese official financing portfolio would be ODA flows, official development assistance, which is what you would imagine traditional aid to be like from another donor country like the US, which would include concessional loans and grants for development projects in developing countries. And then there's OOF-like flows or other official flows, which don't meet the criteria to be classified as ODA as per the definition set out by the OECD. So this would include flows that are less concessional, so less favorable terms than those ODA flows. So this would include non-concessional loans, as well as flows that don't meet the criteria to be classified as development intent. So export credits, which are essentially loans to finance a project by purchasing goods or services from a Chinese company to support that project. So when you compare the portfolio of Chinese official financing from that 2000 to 2014 data set, what you can see, I've included here. So on the left, you see the US, and the green portion of this bar is the proportion of financing that is ODA of this US development assistance. And the red portion there is OOF. So what we just went over would be classified as that. So overwhelmingly, this portfolio of development assistance consists of ODA. This global official finance consists of ODA. And compared to China on the right, you see that only about 25% of this global official finance from China meets the criteria to be classified as ODA, and an overwhelming proportion of it would closer fit the criteria of OOF, And you'll see a lot of export credits as a portion of that OOF financing there. So through the geocoded data set, you can also visualize this breakdown of different types of flows that are part of China's official financing portfolio. And you can see that it's not evenly distributed where these ODA flows are going and the OOF flows. So definitely an interesting visualization to consider when you're working on geospatial analysis. And another variable that you can view in our geocoded data is the sector breakdown. So definitely the infrastructure projects that China is financing globally are the most visible and oftentimes the most reported on. But what we find through our data is that Chinese official finance is more than just hardware for development. It's not just supporting those infrastructure projects that we see a lot of news coverage on, but China is also supporting hundreds of projects in education, agriculture, health, disaster relief. And you can also see subnationally where these projects are being allocated through that geocoded data. There's a lot of different applications that you can use of this geospatial data that we have available. So here I have one example where researchers were able to compare total financing commitments from China at the subnational level in some portion of Africa, and compare that with where the hometowns of certain Chinese or certain African leaders. And what they found was that Chinese official finance disproportionately goes to leaders' home regions, and especially in times of elections. There's some correlation there that they found. There's other sorts of applications that you can make, such as how Chinese aid affects environmental degradation, the impact on household wealth and educational attainment, local conflict. There's all different sorts of insights that have been made using this data. And you could definitely make your own insights through use of this data and through GeoQuery. So although there may be risks, as you saw in the previous slide, where Chinese aid was disproportionately allocated to leaders' hometowns in this sample of African countries, Chinese official finance may improve development outcomes as well. So Chinese ODA substantially improves economic growth from what we found. And also Chinese development projects deliver major economic development gains at subnational scales, which you can find if you were to do a study looking at nighttime light outputs mapped with Chinese official finance projects. And it's worth noting that not all forms of Chinese official financing are equally effective. So as with Western donor countries, ODA definitely has a stronger correlation with economic growth than OOF flows would, which is a substantial portion of Chinese official financing portfolio. So now that we have taken a look at this bigger picture, I want to zoom in a little bit at the process that we use to assemble this data. So what you can see here is that the data set that we have available through our website captures about 4,300 projects. So it's not just that big picture, there's all of this work that goes into assembling this data set. And we have very detailed information on the financing and implementation for each and every one of those projects. And although what we have available on the website now is only for 2000 to 2014, looking ahead, we're actually going to be launching an update to this data set later this year, expanding the year coverage through 2017. And we've also implemented several methodological updates to our process that will lead to a wider breadth of project identification and more depth of project level details there. So a quick overview of our data collection process. It's about 5 stages that we go through. So each of these project entries that you see have gone through a lot of eyes and a lot of scrutiny throughout this process to make it into that final data set. During the first stage here, our research assistants who are employed from the College of William and Mary, they're typically undergraduate students from the college. They go through a huge wealth of different sources that we've identified to locate project level details on Chinese financing activities. And they also do some work to uncover additional sources, typically from the donor and the recipient government during that first stage. And then when they find project level information, they'll enter those details into our database so that we have each individual project record recorded. And then during the next stage of the data collection process, another research assistant will perform additional research on that project to verify that the details are captured correctly, as well as to triangulate the sources there and fill in any key information gaps. During the next stage, which will be quality assurance, an experienced member of our team will review every single project entry to eliminate any errors there and fill in any holes in the data that we may find at that stage. After which, we'll perform logical consistency checks at the staff level to check trends across time and regions, ensure consistency in the coding, compare with external sources of data, just as a final stage to vet this project to near completion for release. And then after that, we'll send the data off to reviewers, both internal and external, for feedback, and then we'll incorporate their changes to data. And then at that point, we're ready to launch the data like we will be by end of this year. So it's definitely a rigorous process that we're going through for this data collection. So when we talk about our open source data collection, there's two different types of sources that we look at. We tend to rely the most on the official sources here as the primary sources that we'll be scraping at that first stage of data collection to identify these project level flows. And those will be Chinese government sources, like from Chinese government ministries or state-owned banks, for example. Recipient government sources like aid information management systems or other sorts of debt registries that the recipient government houses. And also looking for verification from implementing organizations. So if there's a Chinese contractor who's undertaking the project construction, we would go to that company's website to try to find information on different details related to the implementation or maybe the financing contract itself. And then we also look for information from intergovernmental organizations that may report on recipient government debt and different research groups that perform similar work that we do. And then the other type of source we'll look at is supplemental media coverage, including a specific emphasis on trying to find local news reports that can verify different project details, since those are the ones that are most closely tied to the project. And we do perform searches in both the donor and the recipient language to make sure that we have some holistic coverage there in the way that we're searching. So I've mentioned that we have some updates to our methodology, and this definitely impacts the data that you'll see in our next release. So just highlighting here a few of the key updates. We have largely expanded our use of official sources to ensure more reliable and accurate data, which feeds into our larger breadth of project identification and the deeper project level details that we've identified. We have more comprehensive tracking of financing mechanisms so that we can better understand the tools of Chinese financing. So was that really a loan or was that export credits? That will be captured very granularly in our data in the upcoming data release. We also have increased identification of recipient agencies, insurers, and guarantors, so we can better understand the debt burdens and contingent liabilities associated with these Chinese financing activities, so that we can better understand the true development outcomes associated with these Chinese financing activities. And also, and especially if you're interested in geospatial analysis, we've improved our identification of project implementation details, and this includes details related to the geographical location, start and end dates, and the implementing agencies who are undertaking these projects. So I've included here one example of what a project entry may look like, and this is representative of the type of detailed information that we're searching for every single project entry. So like the 4,300 projects from the previous data release, with increased projects that we're identifying now, should all be expected to have this kind of granular information whenever it's available. So in this case, we're looking at a road project in Sri Lanka called the Outer Circular Highway Phase 3. So we've identified the very specific project name that the recipient government uses to refer to this project. We've identified the specific flow, and we've gotten the transaction amount as close as we can to the thousands, even down to the cents in some cases. We find very precise transaction amounts, and the very specific type of flow. So in this case, it's not just a loan, it's preferential buyer's credit, which is one of the main financing mechanisms that's employed by the Export-Import Bank of China to finance projects globally. We've also identified that the receiving agency of this loan is the government of Sri Lanka. So this is adding to that sovereign debt burden there. Since we've identified that in the data, it'll be easier to use that type of information for analysis. We've identified some very precise details around the financing agreement name, the commitment date, as well as the implementing agency, the Chinese contractor who's constructing this road in Sri Lanka, as well as the implementation dates. And you can see that this project was actually completed. The road was open to traffic close to 1 year ago at this point. And we've also, through these sources that we're scraping, are able to find great reporting on geographical location details in many cases. So here you can view an image from the Ministry of Highways of Sri Lanka that shows us where this road project runs in Sri Lanka. So some exciting information you can look forward to in our data release later this year. So to end this presentation on a very positive note, later this year we'll be launching the updated Chinese Global Official Finance Dataset with expanded year coverage through 2017, increased field completeness for all of the projects, including those going back to 2000, a greater portfolio of official sources, and more systematic coverage of geographical information, which you can use as you may for your research agenda. So with that, I will end my talk and open it up to questions.
Thanks, Catherine. And if anyone has questions, feel free to put those in the chat, just like last time. I'll ask one while folks are typing, hopefully. How does China feel about AidData releasing all this information?
I'm not sure how China feels about this. I'm hoping that they won't restrict in any way the type of information that they make available. Yeah.
I remember early on when one of the initial releases hearing about how folks even inside the Chinese government didn't have access to this data, and they ended up using AidData's own work in a lot of their research. I'll ask one more if we don't have any other questions. So you mentioned using various official sources. How did you go about finding those sources in the first place from all these different government ministries and banks and other places?
Yeah, so we have designated staff members who scope out these official sources. And we've generated kind of official source catalogs where we catalog all of the different official recipient government sources and donor government sources, so like Chinese government sources that report on aid flows to that specific country. So for every single country that we track, we have one of these catalogs of official sources where we've done some initial scoping for donor and recipient government sources. And we also reach out in cases to relevant ministries from the recipient government to see if they can put us in touch with the different resources that they have available on these financing activities, or if they can just provide us like an Excel file of these are all of the loans outstanding to China.
We have one more question. How do you deal with missing data or contradictory sources?
Yeah, so in the case of contradictory sources, we rely to the most official source that's most closely tied to the project. So if we were to see, let's say, an intergovernmental organization reporting one figure, but we saw the recipient government ministry across all of their documents reporting another figure, we would tend to defer to the number reported by the recipient government ministry, just as an example. And if there's any holes that we identify in the data, it's increasingly easier to do that since we're systematically scraping the recipient government sources. So it becomes easier to view and gain an understanding of the portfolio of Chinese financing to that recipient country. So as we identify holes in the data, we'll go ahead and create new project entries and then send that through the remaining stages of the process. So that would be created in stage 1, and then it would go through its own process of stage 2 and quality assurance.
We have one more question that maybe we'll come back to at the end, but I'll ask you now. All right, so imagine telling a story using this amazing data in 5 successive frames or in a 20-second animation. What would an example of such a story be?
An example of a story of Chinese official finance?
Maybe a comprehensive way of putting it together?
I'm not sure. I think that I would take it would take a lot more than I think just 20 seconds to talk about, because it definitely varies by country and by different funding agencies and different organizations that are involved in the project. So I think it would be exciting to see different snapshots of how the different projects evolve, maybe viewing any delays in the implementation for some of them and different impacts that are surrounding those projects. But it's definitely more complex than a lot of other financing from other donor countries.
Cool. Scott, if you have more questions that we're happy to chat at the end of the event as well. All right, thanks, Catherine. Our final talk will be by Sydney, looking at how the Geo Boundaries team works to collect and maintain one of the world's largest open source, free and research-ready databases of political administrative boundaries. Sydney?
Thanks, Seth. I am Sydney Furig. I'm a senior here at the college and the managing director, well, one of the managing directors of the William & Mary GeoLab. And so what Geo Boundaries does is we collect administrative boundaries for every country in the world. And the boundaries that we collect are the backbone of GeoQuery. Oops. So a little bit about Geo Boundaries. So we are an undergraduate team of 22 William & Mary undergrads of all majors and all backgrounds, except we're all passionate about open data and research accessibility. And our foremost focus is on collecting the boundaries that form geoboundaries.org, but we also work on projects for external clients. And I'll touch a little bit on that, time permitting. And then our boundaries support GeoQuery, like I mentioned, and then research projects around the world. So what are subnational administrative boundaries? Subnational administrative boundaries are essentially how countries break up their territory to make it easier to govern. So if we're looking at the United States on the right, you can see at the top we have ADM 0, so that's the country as a whole. And then ADM 1, we have all of the states. And then ADM 2, we have all of the counties in the United States. And so this is the administrative structure of the United States. So we have all of these files that we collect, and we replicate this for every country in the world. And as Soren mentioned earlier in the presentation, other countries are a lot more complex in their administrative divisions. I mean, just look at France with their 36,000 communes. So we have all of these data files that we replicate for every country in the world, which is really exciting. And all of the data that we collect is shapefiles. So shapefiles are a common GIS data file format. And this is data that just has like a geographic aspect to it, to where you can map it and it forms a map, such as the ones you see here. So this data is actually pretty difficult to collect. It's a lot harder than you would think for a variety of reasons that I've got listed here. So first off, every country organizes its administrative structure differently. So we have to figure out how a country organizes itself before we can even begin to think about collecting the data. And that also coincides with the issue of knowledge gaps. So there's a lot of data out there, and then it's hard to figure out which data is accurate. And then there's also the fact that some boundaries exist, and we know they exist, but we can't find the data for them. So an example of this is the fact that with Ethiopia, we know that one of their administrative divisions at the most granular level is called a kabele. So it's kind of like a village. And so we know that they exist because there's mention of them, but we can't find any data for them. And so that's a situation that we face a lot of times, and it can be really frustrating. And so that's something that we have to deal with. There's also the issue of conflicts. So if borders change, then the administrative boundaries within them will change. And so that's something that we have to stay abreast of. And then there's also the issue of contested borders. So Geo Boundaries does not take a side in any conflict. We report what the countries say is accurate. So an example of this is Nepal has a contested border with China, I believe, to where they claim area that China claims. And so we have a boundary for Nepal that includes contested space. We have no opinion of that. We just collect that because that's what Nepal says is accurate. And so that's something that we have to remain cognizant of as we collect boundaries, and that's one of our admitted limitations. And then there's also the issue of internal reorganizations. So some countries restructure their administrative boundaries more frequently than others, some after every census. So these are boundaries that are changing every decade, and so we have to make sure that we stay aware of that, so that way our boundaries can be as accurate as possible. And then finally, we have issues with just finding the data itself. So there's the issue of accessibility. We only want free data because we, like sort of mentioned in the beginning, GeoBoundaries and GeoQuery are free. We don't charge people, so we can't pay for data and then share it. So we need free data that's easily accessible and can be shared, and so that's a big concern. And then we also have to focus on the licensure of the data because we need to make sure that we can redistribute it. So these are all factors that make it really hard to collect boundaries and to build a data set like the one that we have. And that's why Geo Boundaries is really unique, because we accept all of these challenges and work to overcome them. And so if you look at other such databases such as GATM or OpenStreetMap, they have these limitations as well. And so it's interesting to see how they go about facing them. And so as a result of all of this research over the past 3 to 4 years, we have created the Geo Boundaries dataset. And so we currently track approximately 300,000 boundaries over 200 entities. And so that's a lot of boundaries. And so we are the largest collection of these boundaries in the world. And we are working toward our 4.0 release, which will hopefully come out this spring. And it's really exciting for us because for the first time, we are going to have 3 different release types. We have the GeoBoundaries open release, so anyone and everyone can download and use the data for whatever purposes. They can redistribute it freely. And then we have our authoritative release, and this is data that comes straight from government websites. So this is the Library of Congress, the Census Bureau, sources of that nature. So this data is the most accurate, but at the same time, they're able to in place more license restrictions. And so that's something we have to remain cognizant of. And then finally, we have our humanitarian release. And so this is data that is only humanitarian use. So a lot of it comes from HumData or the UN. And so we're very excited about this, and we're working on building up our authoritative and humanitarian coverage, whereas our GB Open coverage is global. And so here is a quick overview of our workflow. And so this workflow is completed entirely by undergraduates, which is really exciting. So first off, the first stage is initial research. So this is where our researchers look and identify the actual administrative boundary structure within a country. We have to figure out what's happening before we can even begin to look for the data. And that's where we lead into step 2. So this is the data search. So this is where we actually sit down and look for the boundaries. And depending on the country, it can take anywhere from 20 minutes to 2 weeks or 2 months. So it's a really exciting time. And then the third stage is data cleaning. Once we have actually found an accessible, correct, and good licensed data file, we have to clean it and make sure everything is consistent for everything to go in the database. And this is where we create our metadata. Too many M words. And so this is where we create our metadata, which includes information on the license, where the data came from, the year that the data was created or updated, the canonical boundary name, which is what the country calls the administrative division. So you have communes, you have kabele, things of that nature. And then our fourth stage is quality assurance. So this is where all of the data is reviewed before it ever touches GitHub or the database. And so this is where we sit down and we make sure that all of the metadata is consistent, the shapefiles themselves are consistent, and everything is good to go and accurate. And then finally, our fifth stage is feedback from users. So we readily accept feedback from users across the world on our GitHub page. So users can either let us know if they find a problem in our data, or if they want something new from us, or if they find new data for us. So that's something that we really appreciate, is when users find administrative boundaries that we haven't gotten a chance to find yet. So just a couple weeks ago, for instance, someone found a new file for Kenya that was out this year. And so we were able to update our data for Kenya last week. And so that was really exciting. And that's an important stage and really important to us, and something that we're hoping to grow as we move forward. And so all of this comes together to form the geoboundaries.org website. And so GeoBoundaries is something that is important, and I am biased in saying that, but it's important to understand how the world is divided in order to do research, because everything has a geographic component. You need to know where people are. You need to know where the variables you are studying are. And so by providing these boundaries free for anyone to use and anyone to download, our hope is that research becomes more accessible. And so, like I mentioned, this data is free. You don't have to pay for it. You don't have to make an account. You just click the Get Data button and download the data. And everything can be downloaded in a GeoJSON or a shapefile, and you download based on the country you're wanting and the administrative division you're wanting. And if you're curious about our methodology, there's a technical paper linked in the menu on the left. And so here's an example of just one of the many applications of the GeoBoundaries data. So one of our researchers is very interested in HIV cases, and so he mapped HIV prevalence according to county levels in the United States and compared it against households living below the federal poverty line and uninsured individuals. And so this is an example of how important it is to have county data. And so you can imagine that it's a lot more important in other countries as well. And so that's something that we're hoping to get more into as well. And finally, I want to touch briefly on the other projects and partnerships that GeoBoundaries engages with. So we have a lot of different partners listed here, but I'm going to focus on just a few for the sake of time. So our most important partnership is with the Center for International Earth Science Information Network, or CESIN, out of Columbia University. This partnership has been ongoing for about 3 or 4 years now, and we really enjoy it because it's really meaningful work, because we are working on data that affects vaccinations in Africa as we speak. So over the summer, we worked on cleaning health facility data in Ethiopia in order to aid the COVID response. And we've worked on divining vaccine distribution routes and things of that nature. And so that's something that's really exciting and just another type of boundary. And then we've also worked with the Verified Voting Foundation to collect precinct level data based on polling equipment in Texas and North Carolina for the 2020 election to look at voter fraud and voter accessibility and things of that nature. And so these projects are important to us because we want to engage with other partners, because we believe in the importance of GIS in a number of different fields. And it's also a really great opportunity for our students to get engaged with GIS outside of an academic setting. So that's something that we all really enjoy. And so that's the end of my presentation. So thank you so much, and I would welcome any questions or comments.
Thanks, Sydney. Looks like Dan is stealing some of your questions in the chat. We just got one more though. Do you just keep the most current boundaries in every update, or is there a historical version of the boundaries that is kept and made available as well?
That's a great question. So currently we are working to have the most up-to-date boundaries possible, but looking forward, probably in 6.0 or later, it's a few years away, we have talked about the option of representing historical boundaries, because it's fruitful to show how things change over time.
I've got a couple of questions as well. So you mentioned about all this source information. Is that provided to users as well, about where you got the data from?
Yes. So when you download a file, it'll be a zip file. So once you unzip it, you'll have the shape file, you'll have a GeoJSON, and then you'll also have a screenshot of the license information from the website we downloaded it from, in addition to a text file with our metadata. So this will give you a link to the webpage where we downloaded the data from, a link to the license page, and a lot of other helpful information.
Cool. One more thing, you guys mentioned everything's on GitHub. Can users contribute to this? Can they get involved in the project and give their own boundaries, help out?
Yeah, we welcome it. So last week, someone linked a hum data file for Kenya that we hadn't found yet, so we updated Kenya. And we have one user that's very active. No one knows who he is, but he's always commenting on our boundaries to let us know when they aren't very accurate, and we appreciate him greatly.
Awesome. All right, well, we'll have some more time for other questions on any of these topics at the end. I just want to wrap things up now. Just thank our presenters, Soren, Sydney, and Catherine, for those great presentations. So just a reminder, all these tools, data, methods discussed today are completely free, publicly available, and you can find more information about them and other projects going on through AidData.org and geoboundaries.org. If you have any questions later on, you think of something down the road, you want to talk to us, don't hesitate to reach out to any of the folks in the AidData team, GeoLab team. Hopefully everyone learned something new today about what kind of geospatial data is out there, how it's being used, how accessible it could be, and just some of these really cool projects we're working on. Personally, it was great to be here, part of another Open Data Week event. I just want to thank everyone for attending. If we have any other questions, happy to take those now.
Yeah, thank you all so much for coming. And Seth, I think I did see a question from someone on when the recording will be made available. We've been recording this event, and as soon as we can get it uploaded to our YouTube. So we hope to have that done by tomorrow, and we'll send a follow-up email to all attendees that has a link to the recording, as well as a link to these slides.
All right, we can hang around for another moment, just see if anyone has any questions, but it looks like it's pretty quiet. Soren, I forgot your question prompt about is there any tutorials or guides for GeoQuery earlier on?
That's okay. I think I mentioned during my presentation that there will be links to the tutorial in the slide, and I can also highlight that in my email to everyone who came today. But yes, we have a tutorial for how to use data that geospatial data that you have gotten from GeoQuery and create like a map from it in Data Wrapper. Yeah, we'll also include in the follow-up email to everyone a link to a poll that people can answer if they're interested in being contacted about like having a follow-up training or webinar on using geospatial data and GeoQuery in particular.
Cool.
Well, thank you all for coming and for your nice thanks in the chat. Appreciate it.
Yeah, it looks like that's all the questions, so I think we can go ahead and wrap things up. Thanks, everyone.
Thanks all. Have a great night.